Hello, everybody. Um, Nice to see you too. Uh, uh, so, good morning. I hope we're all keen for the last week of Comp 1511. It's not really the last week of Comp 1511 because, yes, it may be the last week that has lectures in it, but there's a week after that which is going to involve some study and a take-home exam, and then we'll be done for Comp 1511. But good morning to everyone who's up early for the stream today. I see a lot of people saying hi already. Sam was asking how to code Skynet. Skynet already exists because you'll note that most of Microsoft's software is called .NET, and sometime in, I think it was the early 2000s or it was 2010s maybe, Microsoft bought Skype, and I think that they really missed out on the opportunity there to rename it to Sky.net, because that would have been the perfect thing. And then Sky.net could have been just following all the conversations anyone had on Skype and learning how to speak, and eventually how to make Arnold Schwarzenegger. So, you know, anything that can make Arnold Schwarzenegger is a win. Oh yes, thank you for the reminder. Michael is plugging a Facebook event which I mentioned last week, which is going to be a combination event between Women in Tech and CSESOC to do a kind of a support session for 1511 students starting to study for the exam. So it'll be after tomorrow's lecture. So tomorrow's lecture will be 11 to 1 as usual, and then we'll have a break for an hour for lunch, and then we'll hop back into the stream. Not just me streaming this time, there'll be other people with me. We haven't actually figured out all the details about how that's all going to work, but basically a whole bunch of us are going to get together and just do study things for 1511. So those of you who are there in week 1, was it, Michael? Was it week 1 or week 2? I think it was week 1 actually, where we did Lab 0, and everyone got together, and like then it was just like, okay, what does studying at UNSW feel like? What do we do? And what are the basics of getting into C and learning our way around Linux and stuff like that. This time it's going to be a bit of how's the exam going to go? What do we need to do for it? Let's go back over a whole lot of the topics that have been in 1511 and see if people have questions and try to help people out. So this is a case of students helping students. I mean, yes, I'll be there, but I'm not going to necessarily be able to do like one-on-one help for everyone. But I think there's going to be a lot of like little Discord breakout rooms where people can just talk to each other and get a bit of help and stuff like that. So if you're struggling in 1511 and you want to get like, okay, how do I get the basics so I can get over the hurdles for the pass-fail for this course? That's a good thing to think about, and you can go there and ask people about it. There's also an opportunity to just kind of hang out with other 1511 students and things like that. William's asking, how is the night question Comp 1511? So, you may have noticed that in Comp 1511, there are occasionally challenge questions that are way beyond what we teach in Comp 1511, but if you were to piece together everything that we teach, you could extrapolate from that and be able to solve problems like that. Some of those are interesting, some of those are just a challenge, and some of those are to show you that what you've learnt is actually capable of doing much bigger things. Even if you can't do it yet, these are the problems that actually, like that Knights problem, that's, if you've done sort of a couple of years of computing, it's actually quite trivial. So we want to show you where you can end up. And the scary thing is that some people do actually answer those questions. I always find it funny, and I think this is one of the funny things, is that when I first started teaching Comp 1511, I saw questions like that in the exam. So Andrew Taylor was running the course before I was. And I had an interesting conversation with him because I said, dude, why are these in the exam? They're too hard. I didn't call him dude. That's just when I speak to myself. I say dude. It's like, dear senior lecturer Andrew Taylor, hey dude. Oh, the people talk like that to me, and it's sort of more acceptable, I think, because they know that I speak like that. But I said, why is this an exam? I think it's too hard for the students. Like, the questions like this will take me more time than there's the time in the exam. And he said, why don't you just wait and see? And then when a dozen people got full marks in it, and then, about 30 or 40 people other than that still got partial marks in it, so it was worth putting in the exam. I was like, oh, okay. So it turns out that students are better at coding than me. I thought that was really funny. So one of the things I love to say is if people can do all the challenges in the course, then they're hilariously better programmers than me. But what I'm going to do is I'm going to take full credit for any students who are better programmers than me because I'm teaching you. So your success I'm going to take as my own. It's like that's a thing. And I think that talking about the course, talking about Comp 1511 and your computing degrees in general, I consider that the goal of what we're doing here at UNSW and at CSE is, if by the end of your degree you end up a better programmer than me, and better is a dumb word, right? Because there's no one way to measure that. If we always want to look at it, you can be better than someone at something. This is just because they haven't seen it before, and so it's hard to really measure. But if we were going to be really kind of simplistic about it and say, let's all sit down and do the 1511 exam. I have an unfair advantage because I wrote most of it, but even so, having written most of it, I think that there's still going to be some students out there right now who, if I was to give you a 3-hour time limit, would still get higher marks than me in the exam. Pretty sure I'd be very close to the top, but there's still going to be people who are better than me, and that's my hope, is that by the end of your degrees, you're all better than me at it, and you're better than any of your lecturers at a lot of the things that they can do, because that's the whole point of educating you. If we can't take you and send you out into the world to do computing and give you everything that we know, and then take you to the point where you can learn everything that we had to teach, and then develop your own ideas from that, and develop better ideas than we had from that, then we haven't taught you well enough, right? So that's where I want everyone to be, and I know that that's not the case for everyone, because it's pretty hard in 10 weeks to catch up to someone with about 20 years worth of programming experience, so don't worry if it's not the case. But I'm very proud to say that it will be the case for some people, that you'll be faster and more cognizant of what you're doing, and more able to sort of solve problems with ease than I am in C. And I really, really look forward to seeing that when we look at the marks in the exam and I see people that can do those kinds of challenge questions better than I can. Having said that, not super important. Those of you who are hitting those challenge questions already know who you are, because you've been trying to ace and 100% everything in this course. But that's not really the whole, that's not everything, because you don't need to do it. And like, as William was asking about stuff like that Knight's question, is that it's not necessary for anyone in the course to be able to do that under exam conditions. Because even when I look at that question, I'm like, that's going to take me a while. Give me a day or two. And it's like, oh, we don't give people a day or two. So it's not something that's necessary. And so you can have like a full-time position as a computing person. You can have, like, for me, I don't know, like years of experience as an engineer and stuff like that, not being able to do those kinds of questions at speed. They're not super important, but they're interesting. And for a lot of people, I find that for a lot of people find them quite fulfilling to be able to do questions like that. And so I think it's just interesting for some people, but not everyone has to do it. Anyway, let's have a look. What's everyone say, Georgia? The third exam hurdle, not making everyone cringe. I feel like that ship has sailed, Georgia. I think the cringe is happening no matter what. Uh, Sam thinks that it's bold of me to think that he can come up with any original thought. Uh, and Oliver Star is saying it's high expectations that I have of you. Look, it may seem like high expectations or a big deal that I think that you're all going to come up with something new, but there actually is so much that you can do, and I think this is a nice point to actually even just not even launch into the lectures yet, but just think about the fact that you've got a lot of time ahead of you. You've got a lot of opportunities, and I nearly envy a lot of you the joy of finding these things out for the first time. So there's one thing that I don't have as much as I used to. So when I was a student many moons ago, I had a lot more creativity than I have now, and I think the more you learn, sometimes the more your creativity becomes clouded, because every situation that gets put in front of you, you've seen something like it before, so you tend to apply the things that you've learned before. But sometimes the less you know, the more likely you are to challenge the norms of things. So this is one of those funny things where the first time I teach people programming, they ask me questions, and this is really funny because there's a little voice in my head goes, "That's a dumb question. Why would you ask that?" And then like 10 minutes later, I'm like, no, that was a brilliant question, because that was pushing the boundaries of what was happening. That was saying, no, really, what happens when we do this? And I say, well, I haven't done that in years because I've considered there's only one right way to do things. And many of you are going to find new ways of doing things by asking those interesting questions. Granted, 99% of the time when you ask those questions, the answer is going to be, no, that's wrong, don't do that. But sometimes the willingness to branch out and see if there's another way around things is what's going to get new discoveries and new research happening. So there's a lot of people who ask interesting questions like, well, what happens if we do this? And everyone else says, no, there's no way that could work. This is what happened with neural networks. And neural networks are really, really huge at the moment. We're talking deep learning and stuff like that. The current iteration of neural networks, people had basically thought they'd proven that there was nothing more you could do with neural networks. They were this classic thing where people were always laughing about them, because it's like, no matter what you do in AI, neural networks will always be the second best thing. And they were never the best thing at anything. So there was never any point using them. But you could get a decent result if you really wanted to. And then someone like flipped a switch on these, and everyone, well, not everyone, but most people sort of looked at that and said, that's not going to make any difference. There's no theoretical improvement you can get out of neural networks by turning them into deep learning neural networks. And then they started answering all these questions that we couldn't answer with other algorithms. And it was like, wow. So someone just did something that was openly wrong. Not openly, but you know where I'm going with this, right? Like, did something that probably wasn't considered a good idea by the majority of people, and then suddenly it came out to be really useful. So who knows, maybe you will do that. I'm not saying do everything that's wrong just for the hell of it. I mean, yes, experimentation can get you somewhere. Don't do anything that's morally wrong just to experiment with it. Those are different things. But experimenting with your programming and stuff and trying to see what programming languages can and can't do is going to be an interesting thing. And so I encourage everyone to continue that. You can tell that I'm in last week mode at the moment. I'm trying to teach you things that are going to last you the rest of your life, because I know that I'm not going to see you again and stuff like that. Okay. What are people saying? People are singing songs now. gets all the exam questions wrong. Mark told me to. Alright, you can get most of the exam questions wrong so long as you get the hurdles right, and you still end up with more than 50 marks at the end of the course. This is great. Everyone is going to go into the rest of their computing degrees with these wonderful attitudes of openness and experimentation and stuff, and then you'll fail multiple courses. But then, like, you'll fail multiple courses, but you'll have, like, one idea in amongst all those courses, which will just be, like, this brilliant nugget, an idea, and then someone will tap you on the shoulder and go, I want you to do your honours thesis with me because I think that idea needs to be continued. So, maybe. What was I gonna say? Albert Einstein, one of the professors that taught Albert Einstein when he was an undergrad student, said, there was a quote, it was like, you will amount to nothing, or something like that. Someone said that about him. I think it's because he couldn't pay attention to what he was supposed to be working on, because he was thinking deeper into other things. And fully must acknowledge that the university system is a system, and systems only work for some people, because humans are not a system. So it won't always be the case that everything works for you. When I teach something like Comp 1511, I put an exam at the end, and I fully understand, this is actually going into the lecture, this is something I was going to say in the lecture, is that exams are not good for humans. They're not healthy for humans, they're harsh, and they feel like punishment, and you don't really learn anything from an exam. So exams are just there purely to judge you. And being judged is not a comfortable thing for most people. You've really got to do it a fair bit before you're comfortable with it. So, it's only like that because it has to be. If I was going to do this course perfectly, so perfectly means perfect educational goals for you, not for me, because this what I'm about to describe is definitely not perfect for me. I would sit down with each of you. I'd set aside an hour for every single student in the course, and I'd sit down with you and I'd talk to you about the course, about the 10 weeks of learning and about the assignments and stuff like that. At the end of it, I give you a mark, and that'll be super accurate because I'll be able to judge dead certain in person how much you know about programming, and I'll take notes and stuff like that, and I'll go, all right, here's your distinction, or whatever, or HD or whatever. So the idea that we could interview people instead of putting them through an exam, and then we'd find out how good they are at programming. There's a reason why big companies, when they're going to hire someone for potentially hundreds of thousands of dollars over multiple years, don't put you through an exam, but they put you through an interview instead. It's because it's more accurate. And if you are going to invest a whole lot of money in people, then you do that. The downside for that for Comp 1511 is if we started the exam period on the 5th of May like we're going to, and I had 1 hour with each student in a reasonable time frame for what I would do, we would have all the marks out by the end of the year. At best, the end of the year. And I wouldn't be able to teach any other subjects in the meantime. So it's not feasible, which is why stuff like an exam has to happen. So yeah, it's not the best, it's not perfect, but it will get me a good idea of how everyone's going, as long as you actually do it right. I mean, if you don't really sit the exam, or you don't have time to put all of your time and effort into the exam, you may not get a completely accurate reading of how you're going, but as long as you can still get over that barrier of the pass-fail, you'll be fine, you know? Because you're not going to learn anything from the exam, so it doesn't matter if you can't put all your effort into the exam. You learn stuff in the assignments. The assignments is where heaps of your work actually gets done, and your ability to program is developed in the assignments. It's also in the labs and things, but the assignments are the big things that really push you towards real programming, if I want to call it that. Okay, I spent the first 20 minutes just talking about stuff, so let's go into the lecture itself. So what were we talking about last week? Last week we were talking about abstract data types. So we were talking about the ability to split code into different portions, usually in separate files, so that some files can't see what's in other files. They can only see what those other files present to them, and that's in the header file. So the header file provides an interface between two C files that says these are the only things you can use, these functions. So that way that protects the data in some of the C files from being manipulated in the wrong way. It protects us from making mistakes with our own data. but it also prevents a really nice human-readable set of functions that you can use and trust that they're going to work. And so we looked at stacks and queues, both of which are data types that we're going to see again. The stacks, definitely, as you saw, because the example we were using for stacks was how the functions actually stack on top of each other as they're called in the program. So that was sneaking in a bit of sort of the architecture of how a computer organizes your program as it's running it. That's going to come in handy in the future, definitely. So you'll see stacks again. Queues you're quite likely to see again as well, because they're a data structure that we're going to use a lot. Anyone that wants to go into networking is going to see queues all over the place, because one of the biggest issues with networking is when you send information across the world, you're sending all this lightning fast tiny pieces of information. When they reach the other end, they don't reach the end in the same order, because they may not have all gone through exactly the same cables around the world. They hit a certain country and they split up and go different ways, and then they end up in the same place. The wonders of the internet, right? But when they get to the other end, they may not all be in order, so they need to be pieced back together. I'm not going to go into exactly how computer networking works. I'm not a specialist in it either, so I don't claim any expertise. But if anyone's interested in it, there's a whole lot to learn there as well. Okay, today, what are we looking at? So, I probably shouldn't necessarily have spoken for 20 minutes at the beginning about other things, but I still consider it important. But today what we're covering is the exam, what the format of the exam is, and a whole lot of information about it, as well as my tips for the exam, which I had to kind of scramble to write yesterday, because I have a set of tips that I give people for exams, and they're completely different this year than from previously, because your take-home exam has a completely different kind of strategy for it. The reason that I'm giving you a lot of strategy for the exam is I don't want anyone to get caught out by the fact that it's an exam. I do want you to get caught out by the difficulty of the questions, because I want to find out how good you are. I don't want, like, okay, so this is an interesting, it's an honest and interesting thing. I really don't want anyone to complete the whole exam. So you got to take it with that idea. If anyone gets 100% in the exam, it means I've made the exam too easy, because I'm meant to figure out how good everyone is. If a whole bunch of people get 100% in the exam, I can't tell you apart. So the exam is not designed for everyone to be able to answer all of the questions. It's designed for everyone to get pushed right up to their limit, and then they stop at some point. And that's one of the difficulties of a big 24-hour exam like we're doing, is that usually at the end of the 3 hours you stop. So you do a 3-hour exam, you stop, and then you get to go home. You know, you get to finally relax. With a 24-hour exam, you could spend 3 hours on it, and then you could turn it over in your head multiple times over the next like 8 hours, and then go back and get really stressed out about it. And I hope that that doesn't happen to too many people, because it's not really what I intend for the exam or how I want it to work. But we did need to give everyone 24 hours because the start time is not the same for everyone. So the 24-hour exam means that everyone, no matter where you are in the world right now, because a lot of people had to change countries midway through the course, and so I don't want to unfairly disadvantage everyone by making it sort of like a 5-hour exam in a particular window, which would have been, you know, in the middle of the night for some people. So it means that everyone doing this exam has some period of time in the exam that's super awkward for them. And I don't intend for you to be working in that time. I say that the time that you are sleeping is fine, and you really won't lose anything in the exam by sleeping for 8 hours during the 24 hours. Nothing wrong with that, totally fine. You don't need 24 hours to do the exam. It's just a nice open 24-hour window so that people can choose when they do the exam, which is especially in this time of like self-isolation and quarantine and stuff like that. People have a lot more responsibilities to look after the people around them, potentially, than you would normally have. So yeah, so you do the exam in your own time in the 24 hours, and it doesn't have to be all the way through the 24 hours. I should actually talk more about it. I'm jumping into things that I was going to talk about. Anyway, okay, today we're going to talk about the exam. I'm going to give you hints on it, as I said. because I don't want the meta of the exam to be the issue. So I don't want people to have to struggle with the format of the exam. I want you to struggle with the questions, because I want to test how good you are at programming, and I don't want to test how good you are at a take-home exam. So hopefully all the information I give you is enough information so that you're at your best in the exam. But you don't even have to be at your best, because we're on pass-fail at the moment. But we just get an accurate measure of how everyone's going. And then we're going to do a bit of recap. We're going to cover the first half of the course. We'll see how much we get into that. We'll see how deep we get into the first half of the course. I have way more slides than I usually have in a lecture, so the recap might be like bang, 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 and we won't cover things in detail because we don't have a huge amount of time. Okay, what's in the exam? All the things! Hang on. All the things. So, everything that we've been covering so far in the course is going to be in the exam. There are things that are definitely going to be examined more closely than other things in the exam. Those are our sort of core principles of what we're doing, and there's other things that I would consider to be things that are good to know, but you can learn them later without too much risk. And there's things that I consider to be stretch goals, which are things we've shown you that we don't consider you to need to know right now, but it's good to know the idea of them. Anyway, timing and details. Let's get into the meat of this. We are going to start at 9 a.m. Australian Eastern Standard Time on the 5th of May. And that will go for 24 hours. So anyone who is not in Australia, check when that time is. If it's in the middle of the night for you, don't start. Don't start till you wake up, right? Don't wake up at 4 a.m. and start doing the exam. Like, if you're half asleep while you're doing it, it's going to be worse. I'll put my advice later on when I've got slides for it. So, you're completing this on your own computer at home. I'm going to say this about the exam. I decided not to significantly change the exam for the fact that it was a take-home exam. So this is exactly... Is it exactly? It's pretty much exactly what I would have given you if you had been there for 3 hours with no help. So, if you want to go hardcore, like, don't use the internet and spend only 3 hours on it and see how you go. It's still a very hard exam, regardless of whether you use resources or not. But I'll tell you what exactly you have available. So we have auto testing available. Your submissions will be online submissions. Anyone who's done the week 10 lab so far has seen how the auto testing and submissions work. It's only subtly different from how the labs and the weekly tests work. So it's not significantly different. Everything should feel a little bit familiar. So because this thing is still designed for the 3-hour format, we don't expect anyone to take more than, well, if you want to, you can, but to take more than 3 to 5 hours to do it. You can, if you want to, spend 24 hours going at those super hard questions at the end of it, but bear in mind that's not super important and it's not necessary. I have people teaching you at the moment who didn't complete the final question in the exam, like that Knight's Move question that's in the lab and stuff like that. I have people who I'm happy to say I trust that they know everything in the course and they can teach it. So I have people at that level teaching you who didn't complete the final question in the exam. So if you want to, it's cool, but it's like a challenge question. It's nearly like bonus marks. Also, I have people who got HDs who didn't even attempt that final question. So, I shouldn't spend so much time thinking about the final question. The other questions are much more important. Anyway, you can submit more than once. It's just like submitting your labs and your assignments. You can submit more than once. Obviously, we mark the last thing that you submit in the 24 hours. If you've done the week 10 lab, you've seen a bit of what some of the questions and some of the answers are, and just the process of doing it. If not, you will do it sometime this week. we will be contacting you via your UNSW email address. So whatever email address you've been receiving things like the WebCMS notices on, it will be your zid@student.unsw.edu.au. Keep that one open and keep checking it during the 24 hours of the exam, because that is the way that we'll communicate with you. It won't be via WebCMS notices because they've got a timing delay and stuff like that, but I will be pinging you on that email address, and there'll be things like, okay, we're going to start soon, we've started, there's this much time remaining, and all this kind of stuff, so that you can see exactly what's going on. So it'll get a little bit spammy in that 24 hours, but I think there won't be that much. Like, I'm not going to be like emailing you every 5 minutes or anything. You have 23 hours and 16 minutes remaining. No, nothing like that, right? But you do need to be checking that, because if there's anything that's big and important that the whole course needs to know about, it'll go to that email address. So easiest way to check that is if you've been getting my weekly notices of like, this week in Comp 1511, this is what's happening and that kind of thing. That should be, if everything's set up correctly, that should be the same email address that you're going to receive information about the exam from. So the exam is open book. This means all of the class resources are open to you while you're in the exam. Also, any resources you want to look up online, you can Google anything you want. I do want to say that this is still an exam, right? This is still an entirely individual assessment. So regardless of the fact that you can Google things, you cannot talk to other students during this. So this is not an exam that is based on whether a group of students can collaboratively solve problems. This is whether you can solve the problems on your own. So you are not supposed to talk to each other, and you're not allowed to get external help. So you can't share anything from the exam online. So we can consider it like an intellectual property thing, that like the exam and all the text in the exam, we retain ownership of it. You are not allowed to publish it anywhere. You're also not allowed to ask questions about the exam online. So it's nearly like, if you would think of it like this, you take a frozen snapshot of the internet at 9 AM when the thing starts, and that's the internet you can use. So you can't ask any questions during the exam and have someone else answer them, because that's the whole point, right? The point of examining you is for us to find out how good you are at programming. Also useful for you to find out how good you are at programming, and so there's no discussion about things, because then you get help from outside and it doesn't work. You can ask questions and share code with 1511 subject staff. So we will have the Ed forum running during the exam, but the only kinds of questions you'll be able to ask during the exam are private questions. So there won't be anything on the forum from students that other students can read. So it'll be exactly like an exam, where if you put your hand up during an exam, an invigilator will come over to you and you'll be able to say, hey, my mouse isn't working. And we've had that happen in the lab exam where we run the labs, and it's like, okay, we need to fix this person's mouse. Takes us 10 minutes to do it. We give them a 10-minute extension, that kind of thing. So if you have problems, we're envisaging there's probably going to be more problems, because you're all on different computers all around the world, that if there are problems like that, we have the ability to extend the 24-hour period for some students if they have issues or anything like that. So the Ed forum is very good for you to ask for help, as well as an email address that we've set up that specifically goes to the group of us that are monitoring the exam. So this is also for us a level of invigilation we've never had to do before. So we don't usually have to invigilate an exam that goes over a full 24-hour period. So some of your tutors aren't going to be sleeping properly during this exam. Just for anyone who happens to be working in the dead of the night Australian time, for people who are working internationally and stuff, one of us is going to have to stay up and watch the forums during that. I should say one thing about the no communication between students and the no external help. We've already found some people who we know that people cheated on the first assignment. I don't know if any of those people are in the lecture right now. I'm obviously not going to name and shame people right here and now. But yes, we know that you did that. We have ways of finding this out. It's not that hard for us to find this out. Don't do it in the exam. That's the only thing I can say to you. If you actually want to pass the course, and I can understand that maybe assignment 1 was a moment of desperation, so you used someone else's work or you shared work with other people. Just don't, because if you do it in the exam, you're guaranteed to fail the course. I'm going to give most of those people 0 in the first assignment, which means you'll still be able to pass the course. You can consider this the warning that we have the same systems running on the exam, so we'll find out if people hand in the same code as each other in the exam, and if that does happen, then getting a 0 for the exam pretty much guarantees that you can't pass the course. So it's not worth it, especially not in a situation at the moment where it's an open book pass-fail. All the information you need to pass this course is in the information available. Like, you could even not even use the internet, just use my slides and videos. With 24 hours, you can watch nearly everything that you need to in a leisurely fashion, and still complete the exam. So it's not worth it. Like, it's not going to help you. So please don't, especially if you've been in the situation where, like, I'm not gonna judge why, because I know that a lot of people reach a point of desperation, and cheat in assignments because they think it's their only way out. I just want to say to you, it's not the only way out. It's going to cause you more problems in the long term if you do. So if you're having trouble with the exam and you're considering asking other people for help, ask us instead. I mean, we won't be able to just like answer questions for you. We're not going to look at your code and debug it for you or anything like that. But even if you just want to be like, this is not working out very well, you might be able to send a message on Ed or something, and at least have someone else go, look, I'm a tutor, I was there last year, the year before, or something like that. Go take 15 minutes, take a break, come back later with a fresh mind, which is much, much easier to do in a take-home exam, because you can just like shut your computer and walk away for an hour and come back. If you were to do that during our actual exam, then you'd be in a lot of trouble, because losing an hour out of 3 in a 3-hour exam is very difficult and very harsh, whereas losing an hour in a 24-hour exam is like totally no problem at all. I'll talk about that when I'm talking about advice about the exam. So the questions themselves, this might change, but it's probably not going to change. Highly unlikely to change. This is the setup we have right now for the exam. 10 short answer theory questions. They will either be multiple choice questions or really simple things like tell us a small amount of text. Like, show us what would be output if this kind of code was run. So we've got 3 of these questions in the tutorial, so you can see how they're not necessarily pure coding questions. There was one question about what types of issues do you think are happening style-wise in a piece of code. So I took a piece of code and just chopped it up and made it not entirely stylistically perfect and said, okay, which issues do you think are in it, that kind of thing. Or there's some things which are like, here's some code, what should it do? So you can play around with the code and test it and see whether you think it's doing what it ought to be doing and then give an answer, that kind of thing. And there's also 7 practical questions. The 7 practical questions are very similar to lab and weekly test questions. They range from the easy questions, which are always the early questions in the lab and the weekly test, through to the diabolically difficult. I'm going to go through these in a bit more detail in a second and tell you about each of those, but I just want to tell you that there's these 17 questions. The marks distribution is, I don't know if I put those in the slides. I'll edit the slides as I go along about the marks distribution, because I have more detail about all of these things as we're going along. Okay, my tips, how to survive a take-home exam. I had to edit my tips a lot because I have a set of hints for how to do exams at university. Yours are going to be hints about take-home exams, which is slightly different, but a lot of it is similar. Drink water. Drink water. I mean, it's a really, really weird but simple thing. Dehydration lowers your brain function. It doesn't openly make you stupider, but kind of does. Like getting dehydrated is a distraction. Anything that even mildly distracts you from things leads to the potential of making mistakes. So it's not going to make you stupider, but it's going to make you feel like you can't solve problems as well as you normally could. So look after yourself physically. That means keep drinking, eat decent meals. I don't know, like I can't really force anyone to eat or anything, and I don't know what your home situation is like. Not everyone can always afford great meals all the time. I know that you're students, and being students means it's hard to work, and at the moment super hard to work, but at least try to eat something. So the amount of blood sugar that you have affects how well your brain is working. If you eat too many lollies, you spike up and down, and so you think really well for a short amount of time, but then you drop off and you don't really know when that's going to be. You can have a big pasta meal and then you'll have heaps of energy for a while, but it also makes you a bit dozy as you usually digest everything. So you can think about that, because like this is usually not advice that I would give for an exam, but you can actually plan your meal times and stuff like that. But what I hope everyone does is that 24 hours can be a really stressful time. One of the ways to relieve the stress of that is to keep your rhythms the same as they normally are. So go to bed the same time you go to bed, wake up the same time you wake up normally, eat the same way you eat normally, and then work in the times that you find are the best. So you'll know the times that you're sort of most productive for working on assignments and stuff like that. Those are the times you might want to plan to hit the harder questions in the exam, the questions that you think are going to be harder for you. Take breaks as well. So this is the reason why I don't usually lecture for 2 hours straight. Humans can't think for 2 hours straight. We can think for about an hour. This is rough. You know, some people have laser-eyed focus and they can just concentrate for 3 hours straight. I'm not one of those. As you can see, I get sidetracked at random things while I'm talking to you. So you don't have to do that. So if you have the time, you can stretch this thing out over like 16 hours. You don't have to. You probably get the same kind of result if you just hammer the thing out in 3 or 4 hours. But you can if you want to. Not everyone's going to have all 24 hours. So university policy says that you can have 2 exams in one day, which means, considering we have told UNSW that this exam was designed for 3 to 5 hours of work, some of you have other exams scheduled on the same day. Whether those are full 24-hour exams or not, I don't know. But if you do have more than one exam scheduled on the same day, especially if you're someone who has current special consideration for Comp 1511, get in touch with us before the exam. We can probably extend your hours a bit so that you have a bit more time for both. On the topic of special consideration for the exam, we're not necessarily doing the fine-grained time extensions on the exam that we would do, because when we only have 3 hours, anyone who has special consideration for the exam usually gets 3 3/4 hours rather than 3 hours, or even more than that. Sometimes people get 4 hours or more. Because the 24-hour window is so long, we're not initially giving any extensions on the 24-hour window for people with special consideration. However, if this is a problem for you in any way, get in touch with us, because we still can. Because if what you need for your special consideration means that the way that we're running the exam is unfair to you, then get in touch with us, because we'll try to make it as fair as it can be. That also goes for anyone who has inconsistent internet connections, what you consider to be low-quality computing hardware to work on the exam, anything like that. Get in touch with us in advance, and we'll try to make something work for you, because we don't know, everyone's going to have different situations, but let us know and we'll try to help you. Tom, yeah, eat healthily, binge sugar. I'm just like, especially when I say, yeah, just eat the way you normally do, and then you like chow down on the extra large Macca's meal and then try to think for the next hour after that, as that like heavy unhealthy food just kind of slows down your entire system. But you're like, no, I normally do this, it's fine. But it's also the interesting thing about the 24-hour exam is me personally and my tutors and admin staff know this about me, is that sometimes my best working time is like sort of midnight to 3 a.m. And so if I was doing a 24-hour exam, I would definitely do a big chunk of it midnight to 3 a.m. But only do that if that's you, by the way. There's a question there about evenly distributed marks. They're not evenly distributed. I'll talk about that in a second. Okay, let's get into it. Preparation for the exam. So this is very different from a normal exam. Normal exam, I'm like, memorize everything beforehand. Like, think about the things that you might need to do and memorize them beforehand, because you can't look anything up. This time you can look stuff up. So if you want to prepare, preparation now is about getting together your own set of notes if you want to. So you could get a book and write down the things that you think you need to remember, because you've got 2 weeks before the exam. I'll obviously spend this week on the assignment, but the week after that is free for study. If you want to, you can even just go, all right, I'm going to download all of the lecture slides, and then I'm going to write down on a piece of paper the names of all the files and the important bits that I think are in each of those files, so that when I go through the exam and say, okay, this question appears to be about this, I can go back and look at those things. You could even just like text search through the PDFs of the slides looking for things, because I'm pretty sure the PDF slides will have searchable text in them. I would also always have some spare paper with me. I mean, personally, I don't use paper that much, so I'm okay drawing diagrams in Microsoft Paint, because I'm a master of Microsoft Paint, as you've seen my hilarious diagrams. So sometimes I'll do that like that, but when I'm doing questions on linked lists, I don't like doing them without drawing pictures. Super dangerous. So I prefer to get a visual idea of what's going on before I write my code, and sometimes that makes it a lot easier. So those are the sort of tips I have for preparation and also surviving the 24-hour exam. It's totally fine for you to work for like half an hour, go rest for an hour, half an hour, rest for an hour, if your day has that kind of time in it. I don't know how many mature age students we have in Comp 1511 at the moment, but I have a friend who did computing while he had 2 young kids, and he was really funny, because if he had an exam like this, he would literally find 2 hours after they went to bed before he went to sleep, and he would just smash out the whole exam in that time. There's nothing like having children to show you how much you can get forced to do in a small amount of time. So your time management will be your own. I do not expect anyone to work for 24 hours, and I hope that you don't expect yourself to work for 24 hours. You don't need it. As I say here, this is a pass-fail course at the moment. You don't need to hammer the crap out of yourself to get a pass. You can work on the bits that you think are important. And so this is this personal thing from me here. I would say chill out, this isn't a big deal, but no one's going to believe me. But I say it every term anyway. Seriously, it's not that big a deal. It's one exam. You can flunk it. You can flunk it and fail this course, and come back later, and you'll still be fine. In fact, now's a great time to fail a course. I've said this before to people. It's like, I think everyone should fail one course at least during their degree. It teaches you a lot. It teaches you a lot about bouncing back. So I failed a course during my degree. It's like, why is he even lecturing? He failed a course. You get a lot out of it, because you realize that the whole idea of this kind of straight and narrow path that you have to succeed at everything and you have to do everything in the minimum amount of time is kind of bullshit. It's not really super important. Like, I don't know, anecdotally, going through my life, I've had lots of delays on things. It took me nearly 10 years longer than other people to become a lecturer. I had to go off and, fall off the academic tree in multiple different places before I even got here. It's not really that big a deal. Whether you pass or fail this course is not even that big a deal, especially this term, because the university is going to ignore it if you failed it. That in the end, what you learn long term is important. So if you fail this course and you come back next time, and you come back next time with a bunch of knowledge that you picked up, and you go, oh, I can pass it the next time, you know, that's pretty good, and you'll probably learn a lot. And then you might go into your second year subjects going, nah, I know basic C really well now, and it's really easy to learn other things. Sometimes failing stuff gets you better at things. It definitely did for me. The subject I failed was in a particular field of computing. I'm not going to go into details, but every single subject in that field of computing after the one I failed, I got an HD in, including the one that I failed the second time I did it. So, and it turned out to be one of the things I was best at in the end. So sometimes failure is not really failure. Failure is just a form of learning. Anyway, let's move on. So, short answer questions. There are going to be 10 of these, and they're usually going to be multiple choice or just a small amount of text that you need to type in, which might be the output of a program, or it might be a snippet of what code should happen somewhere. And they're going to test whether you understand reasonably important concepts. And some of them are going to test the same things that are in the practical questions, but they're going to be a bit more specific. I should say, let me just edit this. 1 mark per question. Everything that I say here is going to be 99% correct for what's in the exam. If we change it from what's in the slides to the exam, it'll be marked really clearly in the exam. But this is our plan at the moment, is that these marks are worth 10%. They're nearly like a warm-up to the exam to just get your brain going. So you don't have to treat them as like super important. A lot of these questions you could spend literally like 2 minutes on each one, and that's all you'd actually need. So they're not really designed to like really hammer you that hard or anything like that. Tom's writing algorithms about failure and stuff. HSC trials and stuff like that. Oh no. Anyway, let's move along. Okay, so we might ask questions like, what will this code do? You could potentially just copy paste that code into a file and run it, but I want to know how well you understand these things. So yes, maybe you could do that, but bear in mind that might not get you the exact answer to the question that we're looking for, so just think about these things as you look at them. We're testing your understanding of how C works, not necessarily the ability to copy something into a compiler and then press run. So there might be other things that you have to do with them. A lot of them are going to be things like, what is this concept and how does it work? So if we look at a really simple example from say last week's lectures, we looked at stacks and queues. So we might say, I've got a stack and I put stuff on the stack. In what order does the stuff come off the stack? We're not testing how well you can memorize things. We may be testing whether you can go back and look things up though. Yeah. You see some examples in the week 10 lab. So the code style example, just a little hint, that's nearly guaranteed that I'm going to ask that question again with a different set of code and maybe different types of answers. So I might give you that multiple choice, multiple answer thing where it's like, give me all of the issues, all of the code style issues that you think you can see in this piece of code. And you'll be able to get partial marks for that as well. But I mean, like, it's only 1 mark per question. It's not really that important whether you get partial marks or not, because they're worth so little. Okay, so my tips for these. They're a warm-up, but I would still treat them a little bit exam-like. I'd read them all before answering them, and I would say, look at the ones that you think you definitely know. So you might look through them all and go, okay, and there's like question 1, 6, and 8 or something, or you can even write these down and go, I definitely know the answers to these, so I'll answer them first. And then I'll go back and go, okay, I need to think more about these and make sure I'm understanding the question correctly, and I'll spend some time on those. And then if I'm still unsure about anything after that, I'll go, okay, these are the concepts I need to look up, and I'll go back into the slides and I'll look them up. I'll do a text search through my directories of lab exercises and go, okay, what did I do in the lab exercise when the question looked like this? Does this match or not? You know? Or if you really need to, you can be like, The concepts were explained in the lectures at this point. Let me go back to the lecture videos, see if Mark said anything that's going to jog my memory. What I'm saying is don't go hit up the lecture videos for each one of these questions. They're not worth it for the marks. If you spend an hour on each one of these, you're going to use up all of your time. Usually in a 3-hour exam, I'm just like, spend 1 minute on each of these and move on. But you've got more time than that if you need to. But these are a warm-up. Don't burn your whole exam time on these. If the exam's worth 100 marks and these are worth 1 each, you can throw a few of these and you won't notice. You know, in the overall final calculation of your mark, these are worth so little that they may be a rounding error by the time that your final mark is calculated, especially because your final mark is calculated into a pass or a fail. Yeah, ignore these questions. You don't need to answer. No, I'm not saying that, because they're a good warm-up for the other questions. But if you have to ignore them, then do so, because they won't be that important. Okay, practical questions. Less questions, more work per question. These questions are going to look really familiar, because some of these questions are literally lab exercises with the numbers changed. I think at least 1 or 2 of them are probably going to be things like that. But they do have stages of difficulty. The lower the number of the question, the easier it is. So each of these questions you will need to write in a file, and those files will be called q1.c, q2.c, q3.c, that kind of thing. So each of these questions is just going to be one code file. We're not necessarily going to ask you to build a multi-file project in the exam, because we never asked you to build a multi-file project. We taught you about it, but we taught you about it very late, and it's not the kind of thing that we're necessarily going to examine in huge detail. But at least we got you to know how to use them in assignment 2, so we sort of already tested that. But anyway, some of them will have code provided for you that you must continue. Some of them have no code at all, so you have to start them from scratch. We want you to be able to do both of those things. You can access auto tests for these. In this week's lab, you will be able to try that out and try out the actual exam auto testing system. I should remind you that the auto tests are auto tests. They are not a measure of what marks you're going to get. So I have a lot of people who, after the exam, will email me and say, why didn't I get 80% of the marks of this question? I answered 80% of the auto tests. And it's like, yeah, you answered all of the side auto tests, but the auto test testing the core of the question, you didn't get them right. And so don't count the auto tests thinking that those are the marks you're going to get. Use the auto test to tell you that something is right or wrong about your program, but know that your program is going to be marked on whether it's right or wrong, not how many auto tests it passed. This is something that that happens a lot to students when we give you this framework of auto testing. Is we get into the mindset that that these things are an oracle into how well things are working. They're not. Like, computers aren't that smart. They're just a series of things that we put together that might test some things, so treat them as such. There's no specific style marking in the practical question, so there's no marks set aside for style, so you don't have to put comments in if you don't want to. We will be hand marking part of the exam. We will be auto marking part of the exam. So if you think that you need to put comments in, especially if you're working on this over 24 hours, you might forget some of it, put the comments in for yourself. But they won't necessarily be marked, so you don't have to go to great lengths in the exam to make your code readable to other people. I mean, I still think you should on instinct, but you don't have to force yourself into that. Okay, hurdles. This is something that people, I think, want to know a lot about, and I think it's important to know what's happening with the hurdles. So, there are 2 hurdles in the course. One hurdle says, I can use arrays. I'm able to use arrays, I'm able to loop through arrays, I'm able to read things out of arrays and write things into them, that kind of thing. The other hurdle is a linked list hurdle. That says I am able to loop through linked lists. I am able to read values out of linked lists. I'm able to maybe change values in linked lists. It's quite specific, right? I'm not saying that you need to be able to remove and free parts of linked lists. I'm not saying that you necessarily need to be able to insert in between nodes. So the hurdles themselves are a bit lower than everything that I've taught you. So questions 1, 2, 3, and 4, this is in the second part of the course, are the hurdle questions. So there's 2 array hurdle questions and 2 linked list hurdle questions. You do not need to answer all of these questions to pass the hurdles. You can answer just one of the array hurdle questions and just one of the linked list hurdle questions, and that's enough to pass the hurdles. So in question 1 or 3, if you get 50% or more in questions 1 or 3, you pass the hurdle for the array. You cannot attempt question 3 at all and only get 50% in question 1, you will still pass the hurdle, right? So at some point in the exam, in these questions, you have to prove that you can do basic array manipulation. You can just work through the array. I'm going to give you an example of exactly what a question 1 is as well in a second. And then linked list hurdle is the same. So questions 1 and 2 are roughly the same difficulty, but one uses arrays and the other uses linked lists. So they're different difficulty if you know one better than the other. Yeah, exactly what Sam is saying there. Question 1 and 3 are hurdles, but you only need to pass either question 1 or 3 to pass that hurdle. Question 2 and 4 are hurdles, you only need to pass either question 2 or 4 to pass the hurdle. So the easiest way to pass the hurdles in the course, to prove to me that you know enough C to be able to continue on in a computing degree without instantly failing all the subjects that follow on from here, is you put a decent effort into questions 1 and 2, and that covers both hurdles. We've got 3 and 4 in there in case someone stuffs up 1 and 2 by accident and does something strange with what they're doing. Because questions 3 and 4 are harder in questions 1 and 2. So we do expect most of the time for people to get higher marks in 1 and 2 than they get in 3 and 4. But maybe someone has a weird issue and they stuff up 1 or 2 by accident, you kind of get a second chance in the later questions. So those questions are where you can prove whether or not you understand the basics of what we're talking about. I'm going to talk some practical kind of ideas, tips about these before I go into the detail of exactly what they are. Tom's saying he'll let me explicitly answer the above questions. Let me just check. So Olvesto is saying, I keep every time that whoever that is asks the questions, I always not sure about how to pronounce it. Or are the questions covering specific topics, or will they be implementing multiple topics from multiple weeks? They're covering specific topics, but some of those topics might cover more than one thing at once. So if I'm asking a question about arrays, I may be asking a question about arrays that uses characters and strings. So one of the later questions might ask you to work with strings, and it's also testing you about arrays, right? So there's no guarantee that things are just going to be laser-eyed focused on one tiny little thing. The early questions might be. So your question 1, which I'll show you in a second, is actually going to be loop through an array. You have to be able to loop through an array and gather some information. They'll nearly always be exactly like that. No marks allocated to style. That's what someone was asking. At the start of the test, it says not to write any code. Does that include typing anything in the terminal? I can't remember, Francis, where we put that in the test, but I think that's going to have something that is linked to the theory questions. Typing stuff in the terminal doesn't count as writing code. So you can totally do stuff in the terminal, you can run things if you want to. But that might actually be left over from previously where we had the exam in 2 parts, where the first part was you literally couldn't open gedit, and so you couldn't write any code. Now we're sort of opening up that restriction, especially because we're open book now. But the short answer theory questions will not need you to write or run any code. they're designed for you to answer them by reading them and understanding them and writing the answer. So Sam was talking about the hurdles. I think I talked about that. Yeah, 100% on any one of those questions in the hurdles obviously passes the hurdle. Patrick's saying, I'm guessing if you pass all the auto tests, that kind of guarantees 50% for the question. Depends on how you do it. So, not necessarily saying anything about you, Patrick, but if you're taking the piss, you can get 100% in the auto tests. It's pretty easy to say, if the input is this number, I output these numbers, and then if the input is this number, I output these numbers and stuff. So you can write a program that strictly passes the auto tests but does nothing, you know? So I'm not going to say if it passes all the auto tests, it's definitely going to get over 50%, because you can do that. But if it passes all the auto tests with you following the intention for the question, it's highly likely that you are going to pass that, yes. Milkshake Gamer is saying getting 25% on 1 and 3 would be a pass. No, it is not. You have to pass 50% in at least one of those questions. So let me just edit this slide. Or more in at least one question in both the array hurdle and linked list hurdle. That sentence is now too long, I apologize. If I had more time, I would spend half an hour rewriting that line there. But anyway, that's what lecture slides are like. That's what my time is spent doing in the days before the lectures. You have to get 50% or more in either of those questions. So if you get 25% in both of those questions, then it very much looks to me that you don't understand how to do arrays. But if you get 50% one of them and 0 in the other, then I can say you have a decent understanding of arrays, you just didn't attempt the other question, which is fine. Yeah, as William's saying, you need to pass a question individually. And Tom was saying he was getting me to explicitly answer those, which is good. Oliver. That makes a lot of sense that your name is Oliver, because it sounds kind of like that. Can we use things such as switches and for loops, extras that do not throw errors in auto tests in the final exam? Nirma, if you want to, you can. I don't want to say yes, because it sort of breaks the style guide and things, and it's not using what we taught you. I would love you to be examined on what we taught you, rather than random other things that you know about programming already, because I want to know whether you've learnt things from this section of teaching, rather than whether you knew things already and then just came into the course and sort of reapplied them. If you really want to, you can. Like, if it runs. Just make sure that you compile and run everything. If you're going to do stuff like that, actually in general for this exam, log on to VLab and check that it works on our systems, because they're the systems it's going to be marked on. So just be careful if you're going to do anything weird, that it definitely works on the systems it's going to be marked on, rather than testing them on your own computer and your own compiler and then wondering why things don't work later, because different compilers are going to be safer or less safe about weird actions that people take around programs. So I'd say if you're worried, don't if you're going to do anything that's a little bit different from exactly the way I've been teaching things, then just make sure you test them on something like VLab to make sure that they're definitely going to get you the marks that you think you've earned when we mark it on our systems. Tom, what do you chuck in some assembly and some go-tos? Don't do that. I mean, like, yes, that's like you will get the marks because you'll pass the auto tests, but you will have sold a small chunk of your soul to do that if you put go-tos in. Okay, I'm a bit over time at the moment, so I'm going to try to speed. Actually, no, I'll speed up the recap rather than the exam stuff, because I think the exam stuff's important for people to know. Oh, James, I'm going to miss you too, James. I'm going to pretend that I know James. Are students allowed to directly write machine code? See, this is as a tutor, you're not supposed to distract me from the lecture. Actually, no, you're not. You're not allowed to directly write machine code because we specifically say in the questions, write in C this program, and it has to be submitted in a .c file, which is going to be compiled. So no, you can't directly write machine code because your submissions will be compiled. And I can't believe I just answered that question, Michael. Oh, thanks, Oliver. So Paylongly is saying, is the or means they are not hurdle at the same time, or they're both hurdles, and we only need to score 50% for one of them? Well, if it was a logical or, I'm testing you already, if it was a logical or between two if statements. So there was one relational operator, which was greater than 50% for question 1, and another relational operator, which was greater than 50% question 3, and there was an or in between them. Would we need greater than 50% on both of them for the if statement to be true? I love it when it comes back to 1511. Yeah, so let me actually explain that properly rather than just being a dick about it. Yeah, only one of the questions. So if you get 50% question 1 and do not attempt question 3, you will pass the array hurdle. If you get 50% question 2 and do not attempt question 4, you will pass the linked list hurdle. So yeah, you don't have to do all of 1, 2, 3, and 4. Okay. Advice for the practical questions. Again, read all the questions before starting. It's good to know what the general landscape of things is going to be. If you read all the questions before you start, this is why we actually force you to do reading time in the exam, because it's actually much better for you if you're prepared for the exam mentally by reading it all rather than launching in. You'll see which ones are easier and harder than others. We've tried to line it up in a way where honestly the lower numbers are easier than the harder numbers. But that's not always going to be the case for everyone. Someone in the course could be a linked list genius and has just sort of glossed over arrays and doesn't know them that well, and so those questions are actually going to be easier than the other questions. Usually it's the other way around, because arrays are earlier in the course, so they've had more time to just sort of settle in your brain. But anyway, as you read, pick the easier questions, and you can write down on your piece of paper, okay, do this one. This one's going to be really easy, and do this one. Or even like save this one and do it in between the harder questions as a break. You know, you can plan your time how you like. Every question that you're going to answer, write some notes to yourself about how you want to answer it before you do so. Some of the best exam responses have comments in them saying do this, then do this, then do this, and I can see the person just left the comments in there that were notes to themselves about how they were going to perform the tasks. Again, that's something I've taught you, right? Write the comments before the code. Sometimes it works for people, it doesn't work for everyone, but for a lot of people, writing the comments before the code means the code's going to work better. So don't just jump into the code. Think about the question, write down your ideas about it, then start writing code. This is important because in an exam you don't get to talk to people about the solution. So you don't get to say talk to your tutor and go, can I clarify this question? So you want to be able to clarify a question for yourself and make sure you're answering the right question. Because what sucks is if you spend like 45 minutes on something and you go, oh, that's not the question. I've answered something completely different. At least it's code. You can edit your code. You'll be able to change your code to answer the right question if the structure of it is good enough. So it's okay, but I think it's still better to be prepared for what you're doing beforehand. Your labs and the weekly tests are your practice for this. So a lot of people in 1511 ask me about if there are practice questions for the exam. And the funny thing is that if I answer those, a lot of those are like, I get hundreds of emails a week, so it's like it's pretty hard to answer them all. But a lot of the time I'm like, every single question I've given you in this course has been an exam question. They are the same. So the labs and tests are your practice, which means everything that you've learned about debugging and testing your own code in order to get it working is going to come into play here. So I think that that's something that will hopefully help you out. The other thing is, if you answer less of the questions well, you're going to get more marks than if you make a half attempt at all of the questions. So making a partial attempt at a lot of the questions is not really going to get you that much marks. But spending a lot of time on the early questions and getting a lot of marks for them is going to get you marks. And again, I'm going to say this again, don't count the auto tests. Try to get them all. Or use failed auto tests to point you at things that your program isn't doing, and think about how you can get that to work. If you have to, you run out of time, or you just think you can't solve it and you can't get all the auto tests, then that's the way it's going to have to be. If you're in that kind of situation, go back to the earlier questions and try to get them complete, because the earlier questions are more important than the later questions, because they're hurdles. Also, they're worth more marks. I'm going to talk about that in a second. Tom's actually written the if statement there, and William's threatening to do Ruby. Does Ruby work? Can you put Ruby into a C file? No, I think we explicitly forbid the use of C files that access other programming languages, because we're trying to teach you this one programming language. Okay, I'm going to go through the actual questions themselves in the second part and talk to you about what's actually in them. And, oops, while we're here, that's what I'm trying to do. I'm going to put in exactly how many marks these are going to be. So questions 1 and 2 are going to be worth 15 marks each. So you can see that just answering question 1 is more than entirety of the theory questions. The theory questions are there to get you into the swing of doing things without dropping you straight into coding questions. Also, questions 1 and 2 as hurdles are worth more marks than most of the other practical questions, because we consider your core competency to be more important than your extension capabilities or your ability to do weird challenge questions. Your ability to do weird challenges maybe differentiates you from other students, but that's not the important things that we think you definitely need to know. So, what do you need to do in the first 2 hurdles? The first 2 questions, so between these 2, they're worth 30% of the entire exam. So that's a lot. That's nearly enough, depending on how you've gone in the rest of the course, to pass the whole course, right? And this is important, because this is what we care about. We care about whether you can do the basics more than we care about whether you can do fancy schmancy stuff. So, can you make a C program? Can you make the file, and can you get it to compile? Can you use things like variables? Can you do scanf and printf so that you can get some kind of input and output happening to a terminal? Can you use if statements? Can you use loops? This will be a reasonably low level of complexity, but it'll still be there. Can you possibly, it's not always going to be the pet case, but can you read command line arguments and possibly convert them to ints and doubles? We may or may not push this that much in the first 2 questions, but there's a possibility, so I've got that there in case. Question 1, basic use of arrays with ints and doubles. So I'm saying arrays with ints and doubles, so I'm not saying that you need to be able to do arrays of structs in the first question, because the first question is going to test you on your use of arrays, not on your ability to do complex custom variables or anything like that. Basic use of linked lists with ints and doubles is question 2. Let's look at some examples. So this is an exam question, I think, from previously. So I used this one as the example, because we won't ask you exactly the same question again. This might even have been a lab question this term. I can't remember. There's just so many little lab questions. I can't remember exactly all of them. But here's a function, and you're asked to edit the function, so you do also need to know a little bit about functions. But even if you don't know functions, we will probably have given a structure for this question, and it's called evens, and we give you a length and an array of numbers. So you don't know anything about the array of numbers, but we have told you what the length is. And the way that this is called is dot/evens with 13, 14, 15, 16, 17. So a series of numbers, and you are supposed to print out every even number in the array on its own line. So you go through and you print them out. This involves knowing how to loop through the array, and while you're looping through the array, I'm just giving away the code, while you're looping through the array, that's why it's called a while loop, by the way. While you're looping through the array, you look at each of the elements and you test whether they're even, and if they're even, you print them out with a new line on the end, right? So this is code where if you looked at my lecture demos for looping, and you had a reasonable understanding of them, you could apply them to this situation. So this is a hurdle. This is something that I consider to be basic knowledge necessary for someone in Comp 1511 to be able to move on to other courses. I know how to use an array. I can access elements in the array. I can use a loop to go through all of the elements of the array, and I can take some action based on some conditions in it. So you can already see I'm testing if statements, I'm testing arrays, I'm testing ability to use variables, I'm testing ability to use some really basic maths on those variables. So all of those little things I consider to be core competency in Comp 1511, which is why this is a question 1. Here's an example, question 2. Perform some kind of computation on a linked list involving passing through the linked list and seeing everything in it. So I might give you this thing called sum list, and I will give you the structure for a node. In this case, it's a node that stores an integer, and I will give you a pointer to the head of a list. Sum list, and this program is going to build the linked list. You don't have to build the linked list. The program's going to build the linked list, but you have to do the function that says, given a linked list, can you add up all of the values that are stored in that linked list? So what you're going to have to do is you're going to have to loop through the linked list, read the data values from the linked list, which you will be able to see the structure and how to access it, because the structure will be in the same code file given to you. And we're asking you to keep a running total of all the numbers that you've seen, add them all up together and print it out. So you can see what I'm asking you to do here. I'm asking you to be able to loop through a linked list. I'm asking you to be able to keep track of a variable outside of a loop. I'm asking you to do some basic arithmetic, so some basic accumulation of a variable. So again, I'm testing whether you can use variables. I'm testing whether you can do something with a list. I'm testing whether you understand the idea of the curly brackets. So remember, what goes on inside the curly brackets stays inside the curly brackets. If you want something to exist outside of, you need to decide where it is, that kind of thing. So this kind of question tests a few of those other things. And the fundamentals, all of the fundamentals, the building blocks that lead to more complex things in programming in C are going to be in these first 2 questions. So you can expect that kind of thing to happen. Other questions? Hyundong Xiao is saying, would most questions require us to code the main function as well, or just certain functions? Yeah, heaps of them are going to say, here's nothing, code the main function itself. So the whole program has to do something, especially later on. We won't give you any help. You have to build it all from scratch. Sometimes we'll say it's a specific function, you have to edit it, and that's if we want to structure it a particular way. So with this linked list one, at question 2, we don't want you to have to build the linked list. We want you to be able to use it if it already exists. So that's why it has to be a function, because we have to put some code in there to make the linked list. Later on, we might say, okay, build a linked list from these elements, and then you'll have to do something with it. Tom's saying, question 1, would we be asking people to read from argc, argv on your own? Unlikely, probably not. In fact, I actually think that line's not meant to be there. That's probably a question 3 and 4. I'm going to take that out now because we haven't confirmed all the questions. We can still change them. So I'm going to say that we are not asking for command line arguments in questions 1 and 2 because they're actually quite late in the course and they're not a core competency that I consider you to need. So I've just made a decision then. So I don't know if we'd already started doing that with the questions. I don't think we had, and so I don't think that's actually going to cause us a problem for me to remove that. Yeah, so as Michael's saying, some will give you starter code, some won't give you starter code. Eamon's asking if there's going to be lectures next week. No, this is it. Tomorrow is our final lecture together. Okay, so questions 1 and question 2, I've gone through them, or I've gone way over time. Anyway, but I think it's important for me to talk about these things anyway. Question 3 and 4 are harder hurdles. So they are also worth 15 marks each. Am I right here? 15, so that's 30, 60. Yes, I am right. Am I right, Tom? We'll see if this adds up. No, wait, these are worth 10 each, yeah? If you can do some little, like, really simple maths for me in the background, Tom. Aren't we doing a weekly test this week? I think we might be doing a weekly test this week, which is some past exam questions. Yeah. I will confirm exactly, because if these are 15 marks each, so 1 and 2 add up to 30. 3 and 4 also add up to 30. That's 60. And then 5, 6, 7. Oh, no, these are worth 10 each. Yeah. So, 10 for the multiple choice. 30 for questions 1 and 2, 20 for questions 3 and 4, and then 5, 6, and 7 are worth 10 each. That means these are worth 15 each. Sorry. I do have this written down elsewhere, but I'm not going to open that stuff that I've got written down in, because that has what the questions are going to be. Okay, so 4 by 15, 3 by 10, 1 by 10 is 100. Oh, you were right. Okay, yeah, so these are worth 15 each. Okay. We'll figure this out later. We will let you know exactly. And even if we put it in the exam, as I said, if we do need to change stuff between now and the exam, especially like tiny things like how many marks they're worth, which you doesn't change how you're going to prepare for them, we will put them in the exam paper itself, rather than me trying to do the maths in my head right now when I'm supposed to be explaining things to you. Okay, question 3 and 4. They are harder hurdles. We will be also looping through data structures like arrays or linked lists. We might be doing weird things like looping through more than once. We might be looping through not just looking through each element once. We might be testing more difficult conditions. We might even be using two-dimensional data structures, like a Minesweeper 2D array, that kind of thing. Question 3 is definitely working with arrays, and question 4 is working with linked lists. Hillary was asking how long. Oh, Michael's already answered that. Yep, 3 hours if this was going to be in person. I'll give you an example of. Wait, did we have? Oh, I thought I had an example question 4. Oh, no, right. The example question 4 is in the lab. It's either question 3 or 4 example in the lab, and that shows you how these slightly harder hurdle questions work. If your aim is to just make sure that you've got the hurdles done, like if you think that you're struggling in the course and you're looking to scrape through as best you can, the questions 1 and 2 are where you want to focus on rather than 3 and 4. 3 and 4 are definitely going to be harder than 1 and 2. Okay, question 5 and 6 is similar to stuff like the I'm just going to edit this. Similar to things like the third weekly test question or the harder pair lab questions. So this is where more stuff is going to be there. So the arrays question, these are always going to be split between arrays and linked lists. The arrays question 5 is likely to use strings rather than just integer arrays and stuff like that. So we're going to test whether you can work with the modified arrays that are strings, which means fgets, fputs, stuff like command line arguments and stuff like that might be in there also. This will also have more manipulation of linked lists. Can you insert in a certain position of the linked list or remove things in particular ways? I'm not saying that we're not going to do that. We might even have insertion or removal of linked lists in questions 3 and 4 as well. I say potentially use malloc and free with structs and pointers, but this is like nearly definitely going to test whether you can do memory allocation as well in these questions. These questions also, when we get to questions 5 and 6, these are the ones where I'm saying if you're not going to draw a diagram about these, you're going to be in a bit of trouble. So there's going to be some thinking and some problem solving here. I didn't teach you methods for problem solving for you to never use them. So I pitch some of these questions at a level where if you don't think about how you want to approach them before you approach them, then there could be problems. So just make sure that you're thinking carefully about the problem itself and how you want to build your data structure around solving the problem. Then question 7 is challenge question for people chasing HDs. So this is I would say that this is pitched at a really particular student, not one particular student, particular type of student in the course. These are challenge exercises. Potentially even the hard challenge exercises are here. Not necessarily the weird trick challenge exercises or the cryptography challenge exercise. The final cryptography challenge exercise is like an entire assignment. A hard assignment as well that had things that we hadn't necessarily taught in the course, but we thought it would be fun if people really, really wanted to get into it. But yeah, question 7 has no limitations on the kind of code that you need to write. So this will be like everything we've taught in the course. Even stuff that we've partially glossed over in the course, we'll be like, no, if you want question 7, you're going to need a full understanding. So hard challenge exercises, things that, all of the other questions up until this point, even some of the question 5 and 6 might have like the question really is kind of laying out a step-by-step of what you do. Question 7 will not do that. Question 7 will just be like, solve this problem. And it won't be like, build this, and then do this, which is like a breaking down the problem for you. Question 7 won't break down the problem for you. You have to do that yourself. This lab has a past question 8. We used to have 8 questions here. So we'd have a 7 and an 8, where the 7 was pretty hard and the 8 was diabolical. So there's a question 8 in this week's lab that you can look at if you want. William was already talking to me about that and saying, what the hell? I also, people chasing HDs, I apologize, there's no HDs on offer. People chasing SYs, very, very high SYs can do this. I mean, look, I don't want to say this actually I do want to say this openly. If all you're doing is chasing marks in university, it's not going to do you very good. Like, it's not do you very good. Because you won't be able to speak English anymore. It's not going to do that well for you if all you do is chase marks. Because if you're chasing marks, then you're confining yourself to the system inside a university, rather than looking at the idea of what you might want to do with your computing career later on. And I really want people to be thinking about that rather than like just passing university, because if all you want to do is pass university, then you've got no plan, no idea about what might be cool to do with this knowledge, which I think is much more important. So if you're thinking about how cool the knowledge is about programming, then have a look at this question, even if you don't intend to answer it. Just look at it, try to break it into parts. There are partial marks for this as well. So if you break it down into the problem down into parts and you only handle some of those parts, you're probably still going to get some marks. But also no pressure to actually complete this question. If you want to, you can maybe write down the general idea of this question and go try to build it yourself later. Do not copy paste the question somewhere, because again, the intellectual property thing is an issue. So if stuff from the exam gets shared online later, we will actually go after the people that did that. That'll be considered cheating in the exam, even if during the exam you didn't get help from anyone else or anything like that, right? So just be careful with that. We own the exam, you don't get to copy the exam, and we have not given you rights to share the exam with anyone, all right? So if you can remember the idea of what the problem was, like even the knight's move problem, you can do that, but but don't copy paste the text anywhere, because that's very, very bad. Okay, so what to study? I'm not really going to be doing much revision this lecture. The basics are important. As you can see from me going through the exam, Knowing how to use arrays and linked lists is important. Knowing how to use both of them is more important than using one of them really well. Okay? So don't get full mastery on one of them and ignore the other. We don't consider it worth continuing beyond Comp 1511 unless you can use them both to a certain degree. And note that you can pass the hurdles by not being able to construct these data structures. Just being able to read through them is enough. So think about that when you're thinking about what to study. Focus on being able to use them well, add on some ability to construct them and stuff if you want to get higher into the marks. There's some questions from the tutorials and labs that you might want to go back to. There's actually some revision questions in the tutorials. I'm not sure if we've flicked the switch to make the revision exercises visible yet, but sometime in the next week we'll have a batch of extra questions, which are just sort of like questions that we could have asked in the labs and the weekly tests that we didn't, and they'll be on different topics, and so we'll make that available later on. We'll get that to you by the end of the week, hopefully. I mean, if not, we'll get it to you before StuVac at least, so by the start of next week. So we'll add sections to the tutorials and the labs, and we'll add a completely new revision section to the website, which has some extra questions. Oh, we haven't flipped the switch. No, I was pretty sure we hadn't flipped the switch yet. People are asking some questions. Oh yeah, the other thing is, especially when we're talking about people like sharing stuff and things, not everyone's exams are going to be the same. This is a regular kind of thing in any kind of digital exam format. It also helps if people start to cheat and stuff like that. People pass around answers to questions. You don't all have the same questions, so it's not worth it. It's not going to help you. So everyone's questions are going to be your own questions, not other people's questions. And especially dodgy if someone then shares some stuff online anonymously. We're still going to know who shared it, because everyone's going to have particular questions written in different ways. It's still going to be fair. It's still going to test exactly the same things, but you're not going to get exactly the same questions. Okay, how important are the different topics to study? These are our core capabilities here. Use of variables, if statements, looping through things, being able to use functions, arrays and linked lists to store information, characters and strings. They might not even be there. In fact, I'm going to move them. Because they're not necessary. I mean, they're super, super useful. And you do kind of need them, but I'm actually going to push them into this second list here. Things that you need to understand, other important things. Yes, characters and strings, pointers, structures, and memory allocation. All very important. I mean, when you think about it, in order to use linked lists, you kind of need to know a bit about pointers at least, and structures. But you don't need to know them really, really well and be able to memory allocate them until you get a little bit further. Stretch goals that I've got here, these are things that will be tested, but not tested at a huge level. So they might only be in stuff like the theory questions, which are not worth that many marks. Abstract data types, not necessarily going to be in the practical questions. Having said that, if I give you a practical question number 7 that's going to use abstract data types, then that's obviously in, but it just depends on whether you use them or not. Because the use of an ADT or not is dependent on the programmer. You can solve the same problems without using an ADT. So these are sort of a little bit tested, but not that much. If you know the important bits and you know a little bit about the things you need to use for the important bits, that's where you're going to get the bulk of the marks in the exam. And in general, this is like what I think you need to know to leave Comp 151 and go on to other subjects. You definitely, if you don't know any of these, you've got a problem in later subjects, so you'll have to catch up on them. I think linked list is the most difficult one in this list. Functions have subtleties as well, but linked lists very much is the thing that I think a lot of people come to me and say, I didn't entirely get that during the course, and so I want to do some more work over the next few weeks before I go into the next courses. So that's the thing I think that'll be the hardest out of the super important things for everyone. Hopefully the second assignment is giving you some familiarity with it, and we'll see how we go. Okay, most of the exam marking will be automated. So just make sure your input-output matches the specification. Auto tests will help you with that because they'll test your output whether it matches the specification. Anything that has a hurdle in it will also be checked by hand. So if you make a little typo somewhere, like you close a bracket in the wrong place or you forget a semicolon, although like honestly, who's forgetting semicolons? Because if you forget a semicolon, you fail all the auto tests. You pretty much know that there's a problem there. And it doesn't compile. I think everyone's hopefully to the point where you know whether your code compiles or not, and you're going to try to at least submit code that compiles. But little mistakes like that are not going to cost you the entirety of the marks for a question. So if you showed full understanding for something and then made a small error, like one character out of place or something weird like that, or forgetting what's inside or outside brackets, depending on how you do that. Some mistakes inside outside brackets show that you don't understand something. But if you showed good understanding of something, you've made a minor error, you probably still get enough marks to get the majority of the marks of the question. Like a minor error like that's usually going to get someone like 80% of the marks. So the hurdles we're going to go over in detail like that, because at no point do we want a computer deciding whether you pass or fail a course. So we're always going to double check that by hand. And the other questions are just going to be marked by a computer. So the theory questions is just going to be just going to pattern match whether you typed in the right thing or not. Questions 5 through 7 are just going to get thrown into auto marking. Whereas questions 1 through 4 we're going to look at really carefully. So it's different from hand marking in the assignments where we'd be hand marking you for style. In this case, we're hand marking for little errors to make sure that you get the marks you deserve. We're expecting results around 22nd of May. We can't guarantee that. We could be early, but we can't guarantee either way. There is special consideration. So one of UNSW's policies for exams is that if you attend the exam and you commit to doing the exam, then you've said that you're well enough to do the exam. So UNSW has this policy where if you turn up to an in-person exam, then you're considered that you got to university, you're well enough to do the exam, you weren't too sick to do the exam because you got there on the day to do it. So if you felt like you weren't going to be able to do it, then you don't turn up, and then you make sure you go to the doctor and get a doctor's certificate and all this kind of stuff. The take-home exam is a little bit weird and different. So basically, if you're not feeling well enough to do the exam at the start of the 24 hours, let us know. Preferably let us know before the exam starts, but if it happens to happen after the exam starts and you haven't actually started it yet, you can still let us know. But I mean, honestly, while the exam's running, if you get sick during the exam and you can't complete it and things like that, make sure you email us. You can make a private post on the Ed forum or email us on this new exam email address, and we'll try to deal with it one way or another. Special consideration for an exam, if you can't sit the exam, usually requires some kind of proof of why you can't sit the exam. It's a little bit awkward in the whole COVID-19 don't go outside kind of thing. Like, if someone's feeling unwell, usually we would not take that into account at all unless there was a medical certificate. I don't know exactly what the situation is on that, on whether people should or shouldn't be just going to GPs for simple things like that. If you have a problem, let us know. We'll try to deal with it best we can. If you can't sit the exam for whatever reason, so I mean, like, we do have a pandemic going around at the moment, so if people have to look after someone who's very sick at the moment, stuff like that, that could potentially be grounds for special consideration. Let us know if you think that's going to be a problem, or if it is a problem on the day, that kind of thing. There is a supplementary exam. We haven't been given a specific date yet, but we know the week that the supplementary exam is going to be on, which is somewhere between the 25th and the 29th of May. There will be a second opportunity to take the exam if you couldn't take the exam in the first opportunity. So if you think that you're not going to make the first exam, make sure that week that you've got some time during that week. to sit the exam, and we'll get in touch with you with details of exactly how that's going to happen. We've got 700 people in this course, so I'm not expecting that we're necessarily going to get everyone perfectly, exactly able to sit the exam the first time. That's why we've got this backup. So yeah, if you need help, please let us know. Until we start using this exam email, actually you can, I think this is up and running already, so you can, if you have exam issues that you think you're going to need special consideration, please email this. If any of you have current special consideration that's active, so a lot of people have already sent us their letters about the special consideration saying that they would normally get more time in the exam, let us know if you need more than the 24 hours. So usually, if it's a 3-hour exam, there's this really strict time penalty on it, and so we will give people like 15 minutes on every hour, so they'll have closer to 4 hours than 3 hours. Because we've got 24 hours, we're not doing that explicitly, but if you have a need for longer than the 24 hours for the same reasons that you have special consideration, let us know, and we'll extend the 24 hours a bit for you. But most people, I think, who have normal special consideration are not necessarily going to need extra hours over the 24. But obviously, let us know. If we need to help you, we'll help you, obviously. Okay. Break time. Because obviously we've got a break every hour. I've just spoken for 1 hour and 45 minutes. I mean, this is just like, because this one took longer, because it was a take-home exam. There's more information than normal. But we're not going to break. We're not going to break because I've only got 15 minutes left. But I'm going to talk about what I was going to talk about in break time, at least. What I usually talk about here in exam is like trying to memorize things. But in general, learning about stuff in a course, human memory is based on recall. Whether we can get stuff back is based on us actively trying to remember things. So things go into your long-term memory the more times that you've thought about them. So you think about things once, and they may or may not go into the memory that you keep forever. Forever is a really kind of odd word to use with memory, because human memory doesn't really last forever either. The meat flesh is inferior to the silicon flesh in its ability to store information. But we can try to put stuff in our long-term memory by thinking about it multiple times. There's a reason why I show you something in a lecture, and then the next week you look at it in a tutorial in a lab, and then the week after that we test some of that in the weekly test. Weekly tests are small, we don't want to pile up too much work, so we can't test everything in the weekly test. But hopefully some of those concepts you've seen 1 week, 2 weeks, 3 weeks, and that is what puts it into your long-term memory. So if you've been doing everything on the timings we've been giving you, some of this helps you do that. I mean, like, this is my job as a lecturer. I've been memory hacking you through the term to try to get you to do things. So you can do that. You can also, if you need to memorize things, you can link them up with ideas. I don't know if anyone's ever heard of the Mind Palace. It's like a Sherlock Holmes thing where you can actually walk through something. Like, you can walk through your house and see the things that you remember in your house, and there's certain things in your house you're always going to remember because you always see them if you link them to certain ideas. Like, pointers do this, the star in the pointer does this, the arrow does this, and stuff. You can actually remember things better like that. Rain saying stacks and queues. Would stacks and queues be in the exam? They will probably be in the exam, but not at a full-on serious level. If you know them and know how to build them, then there might be something like that in question 7, or even in questions 5 and 6. There might be some stack and queue usage, but there might not be explicitly, do you know how they work? 1 or 2 of the theory questions might also ask about them. As a stretch goal, they're not necessarily going to be like, full on there. Okay, let's continue. Okay, starting my revision with only 10 minutes left. We're gonna fly through some of this, and I'm gonna squish it into tomorrow's lecture. So, what did we learn this term? We learned programming in C. There's a lot of memes in this because last term, was it last term or the term before? I think it was last term. I had some students that sent me a package of memes, and so this lecture I just threw all of their memes in at once. Yes. Can I write hello world using C? And that's my answer. It's not a C program, it's just C's. Okay, here are the topics that we covered. This is the technical topics that we covered. There's a bunch of stuff that we covered which was not full on how to write stuff in C, but more general, how do we do stuff with programming, and that's in a separate list. I'm not going to go through this list. Well, I am going to go through this list, but in their own slides. I'm not going to go through it now. But here's a listing of everything. If you wanted to list all of the things that we've covered, I'm pretty sure nearly everything is here. Unless it was something that was like a little bit smaller that was sort of on the side, that is just sort of bundled in with one of these. It's sort of split into a first half and a second half, but not exactly. So C as a programming language. So things that we know about C now. C is a compiled language, and we use DCC as our compiler, but there are others. The compiler reads your code. It goes through line by line and transforms your code into executable machine code, which is like something that we can just, on a clicking operating system, we could double click on it and it would just run. On an app-based system like a phone, you tap on it, it would open. So that's what our programs turn into when we compile them. C programs all have a main function, and that's the point where it starts running. We can compile things with multiple files, and we compile all the C files while we include the H files. So this is not the same introduction to C that I gave you at the beginning. This is now me going over C, knowing what you know about the whole course. Not just at the beginning, I didn't tell you anything about main functions, multiple file projects, or H files, but now I'm going to complete the knowledge we started talking about. Yes, and more memes about C. And yes, I am also very scared when my code compiles the first time. It means I can't see the errors. Input, output. We started with the easy stuff. Printf and scanf. These were functions that someone else had written that we were using in a hash include, and we were using the percent something strings. I've colored them differently, I apologize, to format our data in specific ways, to treat our data as if it's an integer, to treat our data as if it's a string, as if it's character, that kind of thing. So scanf and printf are basic ways that we can get information to and from the terminal. There are other ways to do input-output. We have other functions like getchar and putchar to do single characters, fgets, fputs to do entire lines of text. We can do command line. Oh, I think I've got slides on that as well. And we have functions like string too long, which is not actually the best function name, but things like that function can convert strings to integers. You can go back and look that up if you need to, because I think this is one of the things we didn't spend as much time on. Command line arguments. This is if we put the argc and the argv in our main. These allow us, when we type in the name of the program, to put stuff after the name of the program and have that be turned into variables that we can use inside the program. So the argv is an array of strings, which is going to be whatever we typed in with spaces in between them. And the argc tells us the total number of words that were typed in at the terminal. 0 days asking about the 3-hour time limit. No, there's no 3-hour time limit. So the only thing is that you have to submit by the end of the 24 hours. So if you want to, you can do a 3 hours time limit, but really you can do like 45 minutes, take a break for 2 hours, do another 45 minutes, take a break for 2 hours, you know, depending on what else you've got going on in that day, right? If you have to, then you can block out a 3-hour time and just sort of smash it out. Like, because I know that people have other responsibilities and things, and also it's harder to concentrate at home. That's why I said 3 to 5 hours. If I was putting you in a lab and there were no distractions or anything like that, I'd say do it in 3 hours. But at home, you're not going to necessarily be able to do that. Yeah. Okay, command line arguments. We talked about that. Oh, here's a demo of command line arguments. So this is the variables we can put in our main. And if I wanted to, I could say this number of words is argc, and I could loop through the argvs and print them out if I want to. So if I do this, args hello world, 3 words were args hello world. So that's our command line arguments. Variables. So we've learnt that variables are ways for us to store information in our memory. And when I introduced these to you, I only gave you 2 variables because we were building up things as we go. Now you've got heaps. So ints and doubles, yes, but we have chars as well. we have structs, we have arrays, we have pointers. All of these things are variables. So anything that's a variable, we can change the values stored in it. We can give those values to functions to use, or we can give access to the variables if we give pointers to those variables to functions. So we know a lot more than we learnt originally when we were starting off with variables. If we want constants, so if we want values that are not going to change, they're not even stored in memory, so they can't be manipulated in any way, we can use hash defines to make something a constant. So really simple variables code here. I can hash define a constant here for Goku that's obviously over 9,000. just a little nod there. But other variables here, I can have a variable, I can declare it by saying what its type is and then the variable. More complex variables have more words in the name, and pointers have a star that is just before the actual variable name. We'll talk about pointers in a second if I get there. Yeah, we can change the value of a variable, or we can call it initializing if it's the first time we do that. We can assign a different value. We can also declare and initialize all at once. I think that people are probably pretty solid on variables now. We'll see how we go, right? If statements, I like to think of if statements as questions and answers. You ask a question in the normal brackets. If that question comes up as a true, which in C we don't have true false values, we only have number values, so anything other than a 0 is true and a 0 is false. So if it's not 0, the section inside runs, and if it is 0, then outside, then it skips past the if statement. If statements are the first time we had choices in our code and we let our program begin to think for itself based on the inputs that it receives. While loops and all kinds of looping, because while loops cover all other kinds of loops. I don't think there's any loop that a while loop can't do in a certain way. There might be other ways of looping. I'm just thinking about some in my head that aren't necessarily able to be done with a while loop, but a while loop is something that allows us to run the same code multiple times, so we can go over and over again and do the same kind of action over and over again. Super valuable because this allows us to go through a data structure with identical elements and do the same action on all the elements in the list. Or it can allow us to repeat the same task until something changes and we stop doing that same task. So I could, for example, I think this was a lab exercise, keep taking inputs from standard input and that are even numbers, but when I see an odd number I stop and say that number was odd. So that could be a loop that could potentially go forever, but will stop under certain conditions. Here's a meme about looping. I like it because it gets bigger brain, but it gets worse code the longer it gets into it. So this is just adding 50 to a number, and you could do x plus plus 50 times, or you could loop 50 times adding 1, or you could add 50 on it. So it's actually like inverted. That's what makes it funny. Anyway, some code for looping through an array. This is fundamental code. This code here I expect everyone to be able to do. I expect you to be able to do this without needing to look at this slide. The beauty of the open book exam is this slide's available, so you can just reuse it if you need to. So if I wanted to set an array that started off all as zeros to the numbers 0 through 9, I could use my iterator, my counting index, to go up to the final index, but not up to the length, so that's why it's less than the length, and go through each time going up by 1 and doing the same action as we go. So that's the basics of our while loops there. If we're going to while loop through a linked list, this is also something I expect everyone to learn and understand and be able to use. Is when I'm looping through a linked list, I will start at the first element of the list, so I will usually copy the head into a pointer, and that pointer, every time it moves, will go on to the next node in the list until it becomes null when it goes off the end of the list. Drawing pictures for these is going to help a lot. We have arrays, collections of variables of the same type. Arrays of integers are things we've used a lot. We did heaps of them in the first assignment where we're using two-dimensional arrays of integers. just remember, this is a block of memory. The index tells us how far to go in memory from the start of the array. So 0 is the start of the array, the first element, and then 1 means we move forward 1, and any number means that's how far we move forward to read certain elements. We've got some code here for working with arrays. I'm running out of time, so I probably won't go much further than this, and I'll squeeze the rest into the start of the next lecture. But yeah, so we have seen a lot of code for arrays, like setting up arrays. If we want to, we can set up the array with actual values. If we do the 0, it's going to zero out the array. Anything else is going to try to put values into the array. We can change individual elements by accessing, remember, the square brackets when we declare the array. So when the variable type is there, we're making the array. This says how big it is. When we're using the array later, the square brackets allow us to access individual elements. Okay, I'm not going to go into functions yet. We'll talk about them tomorrow because I am out of time now. So if you have a tutorial to go to, you can head off to your tutorial now. I will start at this point tomorrow. Oh, I just love that meme there. I'm going to put my face on that for fun. Yeah, so if anyone wants to stick around for questions, I can answer some questions now, but if anyone needs to go head off to go to your tutorial now, I suggest you go off to your tutorial, because your tutorial and lab have more stuff today about the exams. It's probably good to head off to those things. Someone was asking about the argv. Why the argv? Let's go back. The argc and the argv, why this is a character pointer array. So it's an array of character pointers. So we can consider a character pointer to be a string, because a string is actually an array, but we can interchange the use of arrays and pointers. If I edit this, there's another way you could think of this. Oops. That is equivalent. A two-dimensional array is equivalent to this. It's written this way because a lot of the times in C standard specification and things, a character pointer is considered a string. So what this is actually saying is the type of the array is string, and it's an array of strings. So if we think of the string as if it was just a type on its own, the same way an int or a double is, this is an array of strings, which is exactly what it is, because it's the words you type in the terminal. And those words can have a certain number of characters. We don't know exactly how many characters they have, but we know that this is an array of them because there are multiple strings. So each string is the character pointer in a sense, and there's an array of character pointers. So the way that we think of argv is it's an array of words, and each one of those words might be with letters, it might be with numbers, that kind of thing. It might have one character or it might have multiple characters. So if I was to say args hello world, this is the first element in this array, this is the second element in this array, and this is the third element in this array. Each of these things is a character pointer, which is a string. So not exactly a string. Sometimes a character pointer is referring to only one character, but in this case, the character pointer is saying, here is the start of a string, and if you want to continue reading it, read along until you get to the null terminator. We haven't covered strings in the recap yet, but I think you probably know a bit about them as it is. Hopefully that gives you enough information about that. Yeah, Michael's saying the same thing. Oh, right. I can't do argv with two sets of brackets because that would imply that they're all the same length, right? I think it's something like that. Whereas we could do a pointer to a set of strings. So for Epic Days is saying, so argv01 is H. This is actually argv0. So argv01 would be, 0 would be the first element, 1 of that one would be the slash. But I think I've got the same idea as, oh yeah, you totally did, yeah. You can access that as this kind of thing, because what you're doing is first you're going to one of the strings and then you're going to one character in the string. But yeah, if I did the 2 brackets there, it makes it a 2-dimensional array, which is a single block of memory where all the words are the same length, and I don't think that's the case here. I think the argvs are all separate words and they're all exactly the right length that they need to be, so they're actually different length from each other, which is ironic because my example here has them all at exactly the same length. But if they were different lengths, they would be different. Oh, okay. AA is asking questions, but you've got answers already. Cool. Yes, and Hugh's intuition there. Oh, I just realized my face was on top of the code that I was talking about. Hugh's intuition there, yeah, that these are not necessarily multi-dimensional arrays, but it's an array of pointers to other. It happens to be pointers to other arrays, but it is an array of pointers which doesn't imply that they're all the same length, which is important subtlety. Yeah. Oh, and Tom has an interesting thing, and that's like that thing that I talk about a lot, which is like, if you're not sure about something, try compiling it and see what happens. So if you change the name of this to this, then your compiler might start telling you the subtle differences between them. It's saying like, I'm not actually getting a 2-dimensional array as input, I'm getting an array of pointers, and each of those pointers is pointing at a different size chunk of memory. Yeah. And so yeah, we can access it with multiple square brackets, because this is us saying, okay, in this array I'm looking at this element of this array. If that also happens to be an array, then I'm looking at a certain element of that array. So if I did 2 there, it's not necessarily going to work unless there are 2s in each of these, but if there are, then it would work. This is super dangerous code, by the way. Just text highlight that the way it's supposed to be. If I wrote code like this, super dangerous, because this will compile, but only when it runs do I know whether something actually has enough length to be accessed like this. So you have to be careful about those kinds of things. But I think we've seen ideas like that before. Okay, did we have any other questions? If anyone has any questions about the exam as well, I can answer them. I had a few more slides and a few more topics of revision that I wanted to cover today, but I'm going to cover them in like blitz lightning speed tomorrow before they do revision on the rest of the course. I do have 2 hours tomorrow to cover revision, so hopefully in the 2 hours tomorrow I can cover the whole of the rest of the course in that same kind of lightning speed of like, hey, here's the thing, these are the important bits, and then I move on. Yeah. I have a feeling that we're done for questions, but I mean, like, we spent a lot of the time today talking about what was in the exam, and I think that was quite important. Again, the idea that I have is I want people to be happy about approaching the exam, knowing that you still need to do all the technical work, but not that you need to use up all your brain power on how to handle the exam itself. So hopefully that'll be okay. Alright, I'm going to wrap it up there. I'll see everyone tomorrow. Tomorrow we've got a big day. It'll be a lot of fun. We'll do revision, where I'm just delivering content to you in the morning. And then in the afternoon, we'll get together and have the big study session together. And that'll be a bit more interactive. I won't just be talking the whole time. Okay, see you soon.